this recording. So remember, I gave you some notes about an hour ago that might have done well for you to go ahead and have written in your notebook. Once I post this video, you can pause it so that you can copy this into your notebook as we're moving on to order of operations today. We also want to make sure that today is a long session. Today is going to be 76 minutes long because we're going to be learning about a lot of stuff in math that I would have spread out this week had the schedule not been so crazy. So we'll have about 76 minutes of math class today, full of new stuff and lots of practice, okay? Then Tuesday, there's no live session. Ms. Neville has training, and you'll have an order of operations, practice 2, that you'll need to complete. Wednesday, there's no live session. You'll have some guided notes that you may have to do. Thursday, we will have a live session, but it'll just be for our MI test. Yeah, I'm going to get you started on your MI test. This will be a day where you are required to have your cameras on so that Ms. Neville can see what you're doing. And then Friday, we'll have a normal live session where we review order of operations and we move on to expressions. So I hope that everyone has had an amazing weekend. Let's go ahead and get to work. So in our notes, we're going to start talking about order of operations. And we started learning last week, I believe, about exponents. I'm going to reteach our exponents lesson. Please write this in your notebook. I'm going to reteach our exponents lesson for any of you who weren't able to come to class or log on to my YouTube and see the video there so that you can make sure that you are right where you need to be for us to keep moving on today. So when we're talking about exponents, it's important for us to know and if you already have these notes, you don't need to copy them again. But if you start seeing new notes on this board that you don't have, you'll need to get them. When we're talking about exponents, it's important for us to know that when we see an exponent, the exponent is the small number in the upper right-hand corner. This is our exponent. And this is known as our base number. It's important for us to know that today because in one of your order of operations practices, I'm going to ask you what is the base number in the exponent. So the base number is the big number here, and the exponent is the smaller number in the upper right-hand corner of beside the base number. When we're talking about exponents, it's basically a short way of showing us how many times that base number is being multiplied by itself. So 2 times 2 times 2 is what this problem is, this exponent is saying, okay? This is called the expanded form. The expanded form. When you're asked to write this exponent expression as in expanded form, it's asking you to basically tell us how many times that base number is being multiplied by itself. I have 2 being multiplied by itself 3 times because my exponent here is 3. So when I have to solve this, it's important for us to know, Ms. Neville made this mistake when she was your age. The answer here is not 2, 4, 6. No, we're multiplying these numbers by each other. So let's look at it this way. Whatever you see here, you'll need to write down if you don't have it. Two times 2 is 4, and then 4 times 2 is 8. So the answer here, 2 times 2 times 2 is 8. So this 2 to the third power, this is called standard form. This is called standard form. Basically, when you just solve the exponent expression, when you solve 2 to the third power, you're writing the answer, and this is called standard form. Get some time to finish writing this down if you haven't. If I go too fast, remember this lesson is being recorded, so feel free to go back and watch it over again. So there's some things we need to understand here when we're writing exponents. When we're writing down exponents, let's use green this time. You may see it written like this normally, or you could see it written like this. On the problems that you'll be working on today, if you see the 2 here, this is my base number. This sign means exponent, and the 3 is our exponent. So there's 2 ways we could see this expression written. We could see it written here with 2 being the big number, 3 being the small number in the upper right-hand corner, or we could see 2 caret arrow going up and then 3. And that's going to be a normal size 3, but if it comes after that caret, it's the exponent. Okay? I'll give you some time to write that down. Our next thing is pronouncing. Pronouncing exponent expressions. Whenever I see 2 to the third power, whenever 3 is my exponent, I could say, and you do need to write this out, guys, 2 to the third power, or 2 cubed. Yes, it's important for us to know that whenever we have an exponent 3, 3 as an exponent is the base number cubed. So 7 to the third power or 7 cubed. 8 to the third power or 8 cubed. And if you have any questions as we're working, I can't see your virtual hand, so just turn on your mic and interrupt me. That's okay. So remember, when we're talking about writing a number, an exponent expression, to use blue now. Example 1. We talked about 3 as our exponent. What if we were to use 2? Well, we want to remember that 2 to the second power is how we say that, or 2 squared. 2 to the second power, or 2 squared. Anytime we have a 2 as our exponent, that means squared. So if Miss Neville were to tell you to write 7 squared, you would write, this is example 2, 7 to the second power. To the second powered and squared both mean that 2 is my exponent. So if Miss Neville asked you to write this, someone turn on their mic and let us know. If Miss Neville told you to write 7 to the second power in expanded form, how would you write that?
7 times 7.
Very good. 7 times 7. And then I want you to solve this, or, oh Lord, hold on, my pen's going crazy. Then I want you to solve this. 7 times 7 is
49.
49. So if we wanted to write this in standard form, 7 squared equals 49, and this is standard form. There's 2 things I really want to make sure you're understanding here. One, that expanded form is when we write out how many times we're multiplying that base number by itself. And standard form is when we basically solve our exponent expression, okay? You also want to make sure you know, anytime I see a 2 as my exponent, I can say the base number to the second power, or I can say squared. So let's do 2 more examples here, because I want to make sure we're understanding what we need to do here. Okay. So example 3, 7 to the 4th power. I would like for you to write this in expanded form and in standard form. I'm going to be calling on a non-volunteer to help us out with that. Standard form or expanded form? And expanded form. So Orlando, when I ask for you to write 7 to the 4th power in expanded form, what should I have written here?
7 plus.
Is it 7 plus?
Yes.
It's times, sweetie. Whenever we're doing exponents, we're multiplying the base number by itself. So we should have multiplied 7 by itself 4 times. 4 times. Isaiah, could you tell me, please, what is the answer to 7 to the 4th power? Seven to the 4th power would equal what? Could someone please turn on their mic and help Isaiah out?
28.
It is not 28. We're not multiplying 7 times 4. We're multiplying 7 times 7 times 7. The answer is 2,401. Remember, we're going to multiply 7 times 7. That's 49. And then 49 times 7. And then that number times 7. And we should have gotten 2,401. Remember, we are not multiplying these two numbers together. We're not multiplying that base number by the exponent. We want to make sure also that we say this 7 to the 4th power. That's how we say this exponent expression. Example 4. Please write this in expanded form and write this in standard form. Take some time to write this exponent expression in expanded form and in standard form. Jalen,
Yes, ma'am.
can you tell me what this expression would look like in expanded form?
5 times, 5 times 5, 5 times 5, 5 times 5, and just keep on going until you get to 6.
Yeah, very good. Okay, and so now let's solve this. Can someone say with their mic on, what is 5 times 5?
5.
25. And then we've got to multiply 25 times 5. And what would that be?
125.
125. And then we have to multiply 125 by 5. What would that be?
625.
625. Then we have to multiply 625 by 5. And what would that be? I'll give you some time. $3,125. And then 3,125 times 5. Okay?
15.
So, go ahead and say it. 625. So 5 to the 6th power, remember what that means, 5 to the 6th power equals 15,625. You want to resist the urge to multiply the base number by the exponent. Resist that urge. And that is 5 to the 6th power. So let's keep it moving. We're now going to be moving directly into order of operations. We're now going to be moving directly into order of operations. And we're talking about an operation. An operation tells us what to do. Just like a surgeon operates on a human, an example of an operation in math is addition, subtraction, multiplication, or division. Okay? When we're working with solving a number sentence, which is what we're about to start working with, there's a particular order we want to go in. There's a particular order we want to go in. What's important here is that we always move. I'm not going to keep this up long, guys, because you need to have already written this or printed it out for your notes. We always work from left to right. That was what I always forgot as a 6th grade mathematician, is I didn't work from left to right. We read from left to right. Solving a number sentence is no different. So when we're solving a number sentence, it's important for us to remember. Uh-oh, I don't want a highlighter. There we go. It's important for us to remember that we're going to solve anything that is inside of parentheses first. We're then going to solve any exponent expressions second. We're then going to multiply and divide. And you can do either one of those. You don't have to do those in 3 and 4. If you need to divide first to move from left to right, you can do that first. And then addition, you do 5th. And then subtraction, you do 6th. Okay? A really cool way to remember this is Pemdas. Please excuse my dear Aunt Sally. That's a really easy way to remember which operations to use first. Let's take some time and look at this practice problem here. It's pretty easy because we don't have any parentheses or exponents yet. But remember, we're moving from left to right. We cannot solve this first. We are not adding 3 plus 7 first. No, we're going to keep our 3 there. And we're going to multiply first. Okay? And 7 times 6 is 42. And then our second step is to now divide 42 by 3. That's going to give us 14. Remember, we multiply first, we divide second, and last we'll add. Okay? We always want to follow that order of operations. So let's go ahead and start getting our hands dirty a little bit. Let's get some practice done. Remember Pemdas, parentheses, exponents, multiplication, division, addition, and subtraction. And let's do our first problem here. We have 15, and I'm going to rewrite it up top. We have 15 plus 36 divided by whatever is happening inside of these parentheses. Okay, so the first thing we need to do inside of our parentheses is solve our exponents. Okay, so we've got 2 plus, what is 2 squared? In other words, what is 2 times 2?
4.
4. So we now have 15 plus 36 divided by, what's 2 plus 4?
6.
6. So now we've done everything inside of those parentheses, and the parentheses are now gone. Now, what do we do next with this number sentence? we're going to divide, okay? So we've not done anything with that 15 yet. 36 divided by 6 is what? In other words, 6 times what number will equal 36?
6.
Very good. And 15 plus 6 is the last thing we need to do here. 21. Okay? That was a lot there. Okay? That was a lot. And I'm going to give you some time to finish writing this down. This is our example, I think, number 5 for today's notes. We want to remember that when we're doing order of operations, we want to make sure we follow that rule very closely. We want to make sure we do everything inside of those parentheses first, then exponents if they're there, then multiplication or division, whichever one comes first, reading from left to right, and the same with addition and subtraction. Hopefully this will get easier as we keep doing some examples together today. And remember, I can't see your virtual hands, so just turn on your mic and interrupt me if you have a question. And I'll try to be quiet between problems to give you guys some time to absorb this. Please take some time to finish writing down this number sentence and how Miss Neville solved it. Miss Neville's about to move on to example 6. Example 6, we have 15 plus, oh, we just solved this one. So I'm going to work it out for you one more time. This actually isn't example 6. This is just example 5. And I'm going to take some time to work it out for you again. This is the same problem from the previous slide. We want to remember that we do not solve these operations first. We're just going to rewrite those here, and we're going to work with what's inside of the parentheses first. Remember, Pemdas. The P stands for parentheses. So we're going to work out what's in our parentheses first, and we have 2 plus 2 to the second power. After we've gotten inside of our parentheses, we're now going to work with our exponents, E. Okay? And 2 to the second power, or 2 times 2 equals what?
1.
4.
4. 2 times
4.
2 is 4. Okay? So now we've got our exponent solved. We have to finish solving inside of our parentheses. So I'm going to rewrite this one more time. We're still not messing with the 15, the 36, the addition, or the subtraction on the outside, because we still have to solve what's inside our parentheses. And what is 2 plus 4?
6.
6. Okay? Now, remember, we can either multiply or divide next. Okay? We don't have any multiplication to do here, so we're going to divide. We're still not touching that 15. It's still staying there. And now we have to find out 36 divided by 6 equals what?
6.
Very good, 6. In other words, 6 times what number will equal 36? And the answer here would be 6. Now, all we have left to do is add or subtract. And we don't have any subtraction to do, so we're going to solve our problem with 15 plus 6. And our answer there is 21. This is the same problem from the last slide. I just was able to write down the steps a little bit more clearly. Any questions here? Ms. Neville, where did you get the? Why did you do? Any of those kinds of questions you want to ask them, please, please. Okay. So let's do another example together. This is going to be, we're going to do all 4 of these together during class today. This is what's going to make class so much longer because I want to do a lot of guided practice with you today. Okay. Take some time, please, and I just want you to write down example 6 right now. I just want you to write down example 6 right now. Don't worry about 7, 8, and 9 yet. So with example 6, we get our first problem where we have an exponent on the outside of our parentheses. You saw here with example 5, the exponents were inside our parentheses. Here, our exponents are outside our parentheses. So we're going to find out what we're going to do with that today. We want to remind ourselves of please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, and subtraction so that we can get this solved. So the first thing I want to do is work in the parentheses. Yes, I'm going to solve everything inside those parentheses first. So, what is 1 plus 2?
3.
3. So now I've got 3 inside of parentheses to the 3rd power, leaving that division there. I'm not touching it yet. And now I've got to work on what's inside of these parentheses. What is 2 plus 1?
3.
3. Okay, so now the next thing I have to do are my exponents. 3 cubed, or 3 to the 3rd power, will equal what? Do not say 9. What is 3 times 3 times 3?
You said solid?
Yes, ma'am.
Oh. 9.
It's not 9, Jalen. 3 times 3 times 3.
27.
3 times 3 is 9. Correct. 27. Okay. Let's talk about how we got that. 3 times 3 is 9. And 9 times 3 is 27. So now we don't have any multiplication and we get to move directly to division. 27 divided by 3 will equal what? In other words, 3 times what number will equal 27?
9.
9. So my answer here is 9. Can someone answer this question for me? Why did I work in this parentheses first before I worked in this one? What direction must I move in?
Left to right. Left to right.
I have to go from left to right. Any questions here? Okay, let's look at example 7. This one looks a little bit because we don't have any parentheses or exponents. So it'll be a little bit easier. But example 7 is going to give us a lesson in which operations to do first, second, and third. Okay. So with with example 7, we don't have any parentheses, we don't have any exponents, so we can skip those two. But we do have some multiplication. And remember, we must move from left to right. So what is 4 times 6?
24. 24.
24 minus, I'm not doing anything in that minus yet, 8 divided by 4. What is 8 divided by 4?
2.
2.
2. And so now I can solve. Now, after I've done my multiplication and division, I can now do my subtraction. And what is 24 minus 2?
22.
22 is my answer. After we do number 8, I'm going to talk about those exponents and parentheses. We're going to have a star statement, something we don't want to forget when we're doing our independent practice today. So, example 8 is different from example 6 because here the exponent is inside my parentheses. With example 6, my exponents were outside of the parentheses. So let's write a star statement here before we start solving number 8 or example 8. If the exponent is outside the parentheses, you are how do I say this? You are multiplying everything inside the parentheses as the base number. So let's talk about what I mean by that, because that can be unclear here. Here, with example 6, I had to do what was inside of those parentheses first. So 1 plus 2 is 3. And 3 was going to be to the power of 3. But here, example 8, this 2 is on the inside. So I'm only putting 3 to the power of 2, not 7 plus 3. If I would have had that 2 on the outside here, I would have exponent powered up everything. But just if I have my exponent beside the number inside the parentheses, that's the only base number I have. And hopefully that will get easier as we practice with it more. We'll be working with order of operations all week and most of next week too. So let's look at example 8. Let's look at example 8. Remember, we have to solve everything inside of our parentheses first. We have to solve everything that is inside our parentheses first. So, before I can add 7 to 3, I've got to work with these exponents. So 3 squared, or 3 to the second power, would equal what? It is not 6.
9.
9. So I'm going to rewrite this. 12 plus, we haven't touched that. 12 plus 7 plus 9. Okay? So we've solved our exponents, but we're still working in those parentheses. And what is 7 plus 9?
16.
16. So now we've done everything in our parentheses. We've solved our exponent expression. And now all we have to do, because we don't have any multiplication, no division, we're just going to now add. And what is 12 plus 16?
28.
28. I feel like they put all the harder ones at the front, at the top. And now we're working with the easier ones at the bottom, which isn't a problem. We need to see the hard and the easy. Now let's look at example 9. Now let's look at example 9. Do you see how I use a checklist up here? And I write it horizontally and not vertically. Horizontally, what I want to be able to do is check off every time I've used up that operation, okay? I also put an X under the operations that aren't there. So, use blue this time. With example 9, we don't have any parentheses. We don't have any exponents. We do have multiplication. And we don't have any division or addition. So we're just multiplying first, subtracting second. That helped me out to be able to see what order I needed to use for my operations. So I'm going to multiply first. 14 minus, we've not touched it. What is 7 times 2?
14.
14. And now I can subtract 14 minus 14 will equal
0.
0. Sorry. I'll give you a little bit more time to finish writing that if you need to. And let's do our last 2 examples for order of operations today. And then we're going to talk about your independent practice today. Examples 10 and 11. Just write down example 10 right now. Don't worry about writing down example 11 yet. I'm going to write Pemdas. Please excuse my dear Aunt Sally at the top of my paper. And I'm just going to check off the ones I have to use today. So example 10 doesn't have any exponents and there's no addition. So I'm going to put an X under both of those operations because I ain't got to worry about it. So I'm going to solve what's in my parentheses first. Hey, which parentheses do I start working in first?
The ones on the left side.
Very good. We move from left to right. So 8 times 9 is what?
72.
72. And 48 divided by 6 is what? In other words, 6 times what will equal 48?
8.
Very good. And now we've done what's in our parentheses. We've done our multiplication. We've done our division. All that's left is to subtract. And what is 72 minus 8?
64.
64. We solved what was in these parentheses first. We solved what were in these parentheses second. And then we did the outside operation. The outside operation that's there. Uh-oh, sorry. Sorry. Okay. Example 11. Go ahead and take some time to write that one down. And I don't know about you, but I'm going to go ahead and cross out the operations I don't need to worry about today. I don't see any parentheses. I don't see any multiplication, no division. I've only got exponents, addition, and subtraction. So I need to solve my exponent expression first. 7 plus, not touching it yet, just rewriting it. What is 6 to the second power? Do not say 12.
36.
36, good. And which operation will I do next after I've done my exponents? Move from left to right. Will I add next or will I subtract next?
Add.
Very good. And what's 36 plus 7?
43.
42. Isn't it 42? 37, 38, 39, 40, 41, 42, 43. Good job. You got me. $43. 43 minus 5. What is 43 minus 5?
38.
38. So I did my addition second and my subtraction last. So let's do this one together as a class. This question is asking us, do 4 times 1 plus 3 to the second power and 4 times 1 plus 3 to the second power, I said it the same way, do they have the same answer? Let's make some predictions. Say yes, turn your mic on and say yes if you think they do have the same answer. Turn your mic on and say no if you think they have a different answer.
No.
No.
They're going to have a very different answer. So we already know the answer is going to be no, because that's shorthand for because, y'all. Let's solve it now. This is where we as mathematicians get to show our work. I'm going to write Pemdas. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, and subtraction at the top of my paper. And I'm not doing, it doesn't look like with any of them I'm doing any subtraction. So I'm going to put an X there. So let's go ahead and write this out. 4 times 1 plus 3 to the second power So remember, we've got to do what's inside of our parentheses first, and we got to deal with that exponent first. So remember, when that 2 is beside the 3, 3 is the base number. So what is 3 to the second power? Do not say 6. Remember, 3 to the
9.
second power. What is it?
9.
9. Okay, so we still got our parentheses here. We work with our exponents. 1 plus 9 is
10.
10. And what is 4 times 10?
40.
40.
Very good. So the answer here is 40, but the answer with this one, we've got our exponents in a different place. All the same numbers, but the location of my exponent makes all the difference. So here, 3 was my base number. Here, the sum of these numbers is going to be my base number. So let's work in what's in that inside of those parentheses first. What is 1 plus 3?
4.
4. Now we're going to do 4 to the second power. And what is 4 to the second power? Do not say 8.
16.
16. So now we have to multiply 16 times 4. Our answer here is 64. So no, we do not have the same, they're not the same answer because, what should I say here, guys? Why don't they have the same answer? Turn on your mic and let us know. What would you say?
Because the exponent is located in different places.
Very good. Okay. So let's talk about what you're going to be working on today. Remember, this lesson has been recorded. So if I erase something too fast or you need me to explain something to you again, we can definitely do that. Okay. So let's talk about what we're going to be doing in Schoology today. Our class today won't end. You don't stop your Schoology work until 1:44 today. Okay, so remember, we don't have a live session tomorrow. So the work that you have to do here, if you don't finish it today, you can work on it tomorrow. Let's talk about what you're going to be doing. So we're going to choose our math class. Okay, then we've got a new orange folder. So weeks 15 and 16, order of operations is where we are. The notes that you should have copied from the email that I sent you are here. You're also going to be completing some exponents practice today and your first order of operations practice. Let me be clear. I do not expect you to finish both of these assignments today in less than 20 minutes, okay? You can do some of this tomorrow. As soon as this whole group session is over, I'm going to pop the recorded lesson into this folder and you can watch it, finish any incomplete notes that you have, or listen to Ms. Neville explain something about this new skill again. Do I have any questions before I dismiss us? Okay, please get to work. Bye.
Bye.
Bye.